Hey everyone, welcome back to another video, and in this video we're going to be discussing a new question. It's an interesting question, asteroid collision, and I'll be discussing about the logic building and also the coding part for this particular question. So it's a kind of a unique question, and we're going to be using the approach of stacks, and that's what we're going to be discussing. First of all, we'll just take a look like what exactly is the intuition and what exactly is the approach that we need to have in order to solve this kind of a problem. So before that, I hope the problem statement is pretty much clear to you, but again, just want to give you the heads up. So basically, it's like the collision of the asteroids that we have to check. So there is an array which has been given to us, and the array is going to be having some negative numbers and the positive numbers. So negative and positive is basically depicting the direction of the asteroids that we are coming with. And you can consider the number values to be as the mass, or you can say the size of the asteroid. So that means if the number is positive, that means the asteroid is moving in the positive x direction, and if the number is negative, that means it's in the negative x direction. And also talking about the value, like I mentioned, it can be the size, or you can say it can be the you can say the mass of an asteroid. So you can see this particular video over here that okay, let me just play this again. Okay, so you can see that, let me just pause this particular video over here. Okay, so 5, 10 and minus 5, that means we have been given 3 asteroids, and plus 5 and plus 10 are moving in this direction, and you can see the sizes over here, that 10 is bigger than the 5. And if I'm playing this is once again, so next is coming as the minus 5. So minus 5 is again like is in the negative x direction movement, and talking about the size, it's less than 10. So that means if these two is gonna collide, right? So what's gonna happen? What do you think? Which is gonna survive at the end? Definitely this 10 is gonna survive, right? So that's what we have to check, that after traversing through the complete array, which is coming and which is which is like remaining at the end. That's what we have to check, and that's what we have to return in the form of array, right? So that's what the approach of this question is. So let me play this and give you some more example. Okay, let me just play. All right, so as you can see that the minus 5 has been removed, right? So because of the collision, the 10 is something which has been survived at the end. So let's play the video once again. Let's take a look on the next example. So minus 2 and minus 1. So this is the catch over here for this particular question. So if two negatives or if two positives are coming, that means they are not going to collide ever, right? They're going to be just moving in the same direction till the end. So that means minus 2 and minus 1, if these two are coming, we don't need to worry about, we just have to add the values, right? We just have to take the same case, like we don't need to do anything. So next is, if these two again, the next element is coming as a positive 1, right? So that means again, these all are not going to collide ever. So that means they're just going to be passing there. We just have to traverse the complete array, and we are not going to be reaching out to any conclusion, and we have to return the same array at the end. So let me play this once again. Okay, so this is the case over here when we, so the only case which we have to make sure that we have to work upon is the case when we have something positive coming in and when we have something negative. Like firstly it has to be positive and then the negative has to come. Then only we have to check for the condition we have to work on. Because if one is moving in the positive x and if one is moving in the negative x, then only they are going to collide. Like in the this particular case, you can see that over here, which is on the screen. So plus 1 and minus 1 are going to collide because plus 1 is coming at the first. Just imagine for a case, if this particular case has been reversed, minus 1 is moving in this direction and plus 1 is moving in this direction. So definitely they are not going to collide, right? So let me just write this down, and this will give you more understanding. Case 1. Let's consider the cases over here. So the very first case is that both are plus plus. Then what's going to happen? We don't need to do anything. Like we both of the asteroids are going to move in the plus x direction, and we won't be able to reach out to any collision. So there will be no collision over here. Case 2. If both are negative, then also there is not going to be any kind of a collision, right? And the third case, which is like one is moving in the plus direction, that means on the right hand side, and one is moving in the negative x direction, then what's going to happen? What do you think? Definitely there is going to be a collision, because this time one is moving in the plus x and the other one is moving in the minus x, so that means there is a collision possible. The case 4 is going to be like something when there is one moving in the negative x and one is moving in the something called as a plus, right? So one is moving in the negative x and one is moving in the right hand side, so that means there is not going to be any kind of a collision. So this is also one of the cases wherein we don't need to worry about. So these are basically the 4 cases, so out of which we have to only compute and we have to build the logic only for this particular case. We don't need to worry about all the other cases, and that's what we're going to be doing in this particular question. So let me just play the video once again so that we can understand this particular thing in a better way. Let me just play this once again. Okay, so you can see that plus 5 plus 10 minus 5 is coming, they're gonna collide, collision happens, plus 10 is something which is remaining at the end. Minus 2 is coming, minus 1 is coming, plus 1 is coming, plus 2 is coming, nothing is gonna happen, right? No collision. Then is plus 2 plus 1 minus 1, definitely they're gonna collide, and what's gonna happen? They're gonna collide, and then after that the result is there. So that's what we have to do, and let's try to build the logic first and see what's gonna happen. Okay, so I hope like after having this particular understanding of this question, you must be able to come to the conclusion that the best data structure that we can use for this question is the stacks, because by the stacks we will be able to put the numbers one by one inside of the pile, and basis on that we can put the logic, and then at the end we can take the elements back out, like pop out the elements from the stack, and then we can have the answer in our hand. So let's try to see the implementation using the stacks. Let me just zoom it a little bit, and also so this is not giving me the option to increase the size. Okay, I hope this is more visible, and let me just write down the logic over here. So basically we are going to be using the stack over here like I mentioned, so we have to initialize this to be with the integer because we have to store the values of the integer data type. And next is what do we need to do? So let me short this particular thing just to make it easy. So this stack has been initialized, and what else? We have to iterate over the elements of this particular array that we have been given. Int I call this as AST. So we're going to be traversing through this array and we'll be checking the value. So like I mentioned, we only have to worry about one single case when the element, okay, so let me just first of all write down the condition for which we have to work on. And also, so like I mentioned, there were only something called as 4 cases possible, right? So for that thing, so in order to compute only that particular single case which we have to work on, I will be creating a block for that, and that block is something called as a collision. So this collision block is something which we have, which will be, taking the case, the only case which we have to work on, and if that's going to be workable, it's going to get enter inside of this particular block. Okay, so that's what we're going to be doing over here. Next is I'll be mentioning the conditions that we have to work on inside of this while loop, so that if that condition is going to hit, it should be working inside of this particular while loop. So the very first thing is that I have to check whether my stack is empty or not. Okay, this empty. If the stack is full, I mean if there is some kind of an element present, then only it's gonna get inside of this particular stack. Okay, else we have to just push the elements inside the stack. Next is, like I mentioned, the condition which we have to check is that this one over here. As you can see that in the example number 3 over here, the coming element is -5 and the present element is 2. So that means the element which is coming out, like the asteroid which is moving in the negative x direction, should be of the greater value, right? So that means, so we'll be just like, let me just explain this particular example completely. 10, 2 and -5, these are the 3 elements that we have in this particular array. Okay, so one by one we'll be inserting the elements inside of the array. So this is a proper case which we have to work upon. Initially the 10 is this number 10 is something because this is the only element. This number will be inserted inside of the stack. Now that we have this element, the next element is going to come, which is number 2, because these two are positive. So that means we can straight away insert this particular element inside of the stack, because these two elements are in the same direction and they are not going to collide ever. Okay. So this 2 is also inserted inside of the stack. Next element which is coming is this -5. This is a -5 element. So we have to check. This is moving in the positive x direction and this is moving in the negative x direction. So that means there is a collision that's going to happen for sure. But over here, as you can see, that 5 is of greater magnitude. So that means what's going to happen? This 5 is something that's going to just go, that means this is definitely going to hit with -2. And this -5 is something that's going to lead or going to remain at the end, because this 2 will be vanish. I mean, this will be broken down. So this -5 is something that's going to be remained over here at the end. So this is what we have to check. So if the upcoming element is of the greater magnitude and it is in the negative x, it is in the negative value. So that means this is something that we have to work upon. So this is what the condition we're going to be adding up over here. S dot peak, if it is greater than that of the 0, and also the upcoming element, that means my I is basically less than that of the 0. This is what we have to check. The element which is at the top of the stack, if it is greater than that of the 0 and the element which is upcoming is less than that of the 0, then definitely we have to work inside of the condition. So let me write down the code completely and then I will explain you what exactly is going on. Okay. And what is the if condition that we have to check? The if condition that we have to check whether the upcoming element is having the greater magnitude or not. So that means S dot peak is less than that of what? Minus of I, because that is in the negative x, that is in the negative direction, right? So we have to put a negation over here so that we can check. And if that condition fulfills, we just have to pop the element out of this particular stack. That's what we have to do. I hope this makes sense. And if that happens, we just have to continue with the block. We don't want to do anything and we don't want to check anything else. So this one condition is met. Next condition is like, if these two elements are also equal, this is also something that we have to check. Just look at this particular case over here. If two asteroids which are of the same value are going to hit, then definitely there is nothing that's going to lead at the end. There is nothing that's going to remain at the end. So that means these two will be collided, and that's what at the end that we have, right? So if my S dot peak is basically equals to minus of I, what do I need to do? We need to pop the element, right? So we just have to pop the element out of the stack. And what else? What the next thing that we have to do? We just have to break out from this particular collision over here, because this is the only condition that we have to worry about. If these two conditions are coming, then only we have to get inside of this while loop. Otherwise we just have to come out of this collision block and we can work on the next element. We don't need to compute anything else, right? So out of this while loop, I will be mentioning my other condition, that if any of the other case happens, I just have to straight away add the element inside of this particular stack that we have created. That's what we have to do. That's what the logic over here for this particular question. So this is the complete story that we have written so far, that we have discussed. So the only case when we have the condition happening, like this one element is moving inside of the towards the plus x direction and the other element is moving in the negative x direction, then only we have to work inside of this while loop. You can see that over here, then only we are working in this while loop. Otherwise we have to just push the elements inside of this particular stack. That's what we have to do. Okay. Otherwise we just have to break out of this collision block and we can just add the element. Now the only thing that that we are left with is that now the stack is full. We have to return our array. So how can we do that? It's a pretty simple thing. Whatever the size of the stack is, we have to create the same size of array, and we have to take the elements one by one from this stack. I equals to s dot size. That's what I have to do, and I will be taking the -1 over here. I will be keep on iterating over the array, and whatever the element that's gonna come, I will be adding that inside of the array. I will do s dot pop. This is a pretty simple thing, right? So we have just declared an array that to be of the size of the stack that we have got, and we have initialized the for loop. So basically we'll be starting from the -1 index, like from the size -1, the last location of this array, and we'll keep on doing till the 0 position, and one by one we'll be popping out the elements out of the stack and we'll be storing inside of the array. And at the end we just have to return our array, and that's pretty much it. So let me just run this particular code, and this is gonna definitely work out. Yep, it's pretty much accepted. 0 milliseconds. Let's submit this particular code, and I hope the explanation was pretty much clear to you. So this is a very simple question. I would say it's not a very tough question, though the understanding, like for the first time, definitely it's gonna give you a little bit of, you would be thinking that it's a little bit of tedious problem, but yes, it's a medium level problem. It's perfectly written as the correct one. And but again, by just doing a little bit of hit and run, I mean by just writing down the condition, you would be able to reach out to the conclusion. And if you have any kind of a doubt, you can put that in the comment box. We'll try to discuss. And yeah, that's pretty much it from my side. Thanks for watching. See you next time.